Good morning, everybody, and welcome to the next in our series of Inventor demonstrations. Today we're going to be looking at automation inside of Inventor, and part of that process, or the main part of this process, is going to be looking inside of iLogic inside of Inventor. This is installed and part of your base installation of Inventor, so no need to install any additional software for this. This is standard Inventor functionality that we're going to be taking a look at today, and hoping just to give you a better understanding of how it ties into the entire system and how we can make better use of iLogic inside of Inventor by adding some clever automation options really inside of our models, inside of our assemblies and our parts. This does pretty much follow along from our modeling environment, so especially being aware of how to use parameters inside of our Inventor part. So if this was something that you haven't had a look at before, I would really encourage you to have a look at our previous videos looking at modeling inside of Inventor, especially the 3D side, and using parameters. If you haven't, or if you have rather, and want to have a look at a bit more intelligence behind making our models a little bit cleverer, a little bit more intuitive, but I hope you'll be able to join us in the rest of this video just to have a look at this in a bit more depth. So without any further ado, I'm just going to hit straight into our Inventor environment, and again we're using Inventor 2023 in this demonstration, but Inventor iLogic has been around for a number of years, so if you are using an older version on subscription, you've already got this available to you. Just going to pop my face on very quickly just to make sure you guys can see me while I'm demonstrating this. So just a second. There we go. Awesome. We're just going to have a look today at the Inventor iLogic side of things. So today we're going to be configuring a table that is going to be customizable in its size, its height, its width, and its length, and we can add some intelligence also to the legs themselves. So I've got an example, a table assembly, but we're just going to start off as we usually would with the actual modeling side of things, and just beginning to ground ourselves from there and build up on the information from within a single model. We can then begin to bring this into an assembly site. So I'm just going to go straight into Inventor using the new button. I'm just going to create a new standard part that we're going to be using inside of our assembly. Just going to use that there very quickly, and just going to make some fairly generic geometry, but the importance behind it is ensuring that we've got the correct parameters driving the values later on. So it's always being aware of what parameters we're going to be needing at the end. We know when we're designing this table, we're going to need to have a height, we're going to need to have a width, we're going to need to have a depth, as well as a few other values that we're going to want to consider with this table. The thickness of the material that we're going to be using, how many supports it's going to need, how many legs it's going to need perhaps. We can always add that retrospectively, but knowing that before you actually go in and start designing the first part is very important, especially when wanting to add in the parameters inside of this. So what we're going to do, standard practice, is we're going to create the geometry first. So if I go into my primitives section over here, I'm just wanting to create a box, a 3D solid essentially from this. So I'm just going to select the box from the drop down over here and choose a plane that I want to put this on. For this particular one, I'm wanting to make the table top, so the top of our actual table. Therefore, I'm going to start on the ground plane and model up from the ground plane. So selecting the ground plane very quickly, I'm going to move my model around so I'm looking at it from the top, with the arrangement correct as well. With the primitive shapes, we start with the center point, so I'm just going to select the center point there, and we're going to pull this out essentially from here. And right from the get-go, we're going to now start naming each of our dimensions. So we know, looking at it from the top, from above, and with the correct alignment, we're going to have our width first, and we're going to have our depth of our table. So the first value we put in here is our width. So I'm just going to type in width is equal to 800. It's going to go black, which means it's confirmed, it's able to have that. If it's red, it's unable to confirm that that's going to be added to our parameters. If I hit tab and switch to the other value, I'm now going to hit the depth, or drive the depth from here. So if we go depth is equal to, let's say 500 for the depth. This will all be changed a little later on, so we're not going to worry too much about that from here. We just want an estimated value essentially to begin with. And then the last value we're going to need is a thickness for our piece of wood, the plank itself. For this one, I'm going to give the parameter thickness the name THK just to make it a little bit quicker to type out and a little easier to spot. I'm going to say that the thickness is going to be equal to 8 millimeters. Hit enter to confirm, and that's that done. If we have a look in our parameters now, that's just popped up on my other screen. Let me just grab it from there very quickly. We've got a parameter called width, a parameter called depth, and a parameter called thickness. We've also got a D3 value, which is the taper angle of the extrusion. We're not going to be too worried about that one. But now if we change the value 800 to 900, the width of our plank changes. If I change that from 500 to 450 or 350 for the depth then changes, and same for the thickness. So we've got those values in there, and it's just important from here to make sure you're sticking to the same naming convention just to make it easier later on. Doesn't have to be the same naming, but just to make it easier later on, we want to try and keep to a simple and similar naming convention essentially for these dimensions throughout all of the parts that we create. Next thing I want to do, just for the sake of neatness, is actually add a fillet to the entire part. We want to make sure that the corners are all rounded. So I'm going to go into my fillet tool, and rather than selecting single edges, I'm going to go select in the options to the right over here that I want to choose an entire part. So an entire solid, I want to fillet all of the edges of that. And you can see it's given me a value there. It's already selected all of the edges of the particular component. And all I have to do now is give that a value as well. I'm also going to name this one. So I'm going to call this one fillet, just so that it's again easier to pick up later on rather than a generic parameter name. So fillet is equal to, I'm going to keep the value at 2 millimeters still. So fillet is equal to 2 millimeters. Hit enter to confirm, and that has now been created. All of my edges have now been filleted for me. If I wanted to, I can come in and assign a material to this as well, just so that it looks like the item that we're wanting to create. So in the material drop down at the top, we've got the ability to come in and assign this as a wood birch, or any of the other wood types if you wanted. Otherwise, there are different appearances as well that we can apply to that. Materials will obviously pick up certain values like the volume, the weight, and a few other parameters from inside of the properties side of things. But now that we've got this looking very similar to what we need, that's essentially what we want for this one. The next thing we want to do for this is ensure that we've got holes in place. So if we're attaching our top to the bottom, we want to make sure that we've got a hole in place, so that if we're adding it by dowels or if we're screwing it into the bottom section, we want to make sure that it can attach, and we're taking that into account for our particular configuration. So I'm going to create a quick sketch on the bottom face of my component or of my part. I'm going to come in and add a line for a guidance point. I'm going to make this line a construction line so it won't pick up later on. It doesn't really matter in this particular instance whether it's a construction line or not, but I think for the sake of neatness, it's generally better just to ensure that if it's not physical geometry that you're placing in, a construction line is generally best for that. So I'm going to hover over the top edge to make sure that it snaps to the top edge, and pull it all the way down to the bottom edge, making sure that that's snapped at a 90-degree angle for this particular one. I'm going to do the same on the opposite side. So I'm going to pick that top edge and do the same opposite side at a 90-degree angle. Make sure it's snapped both places and all nicely done. We want to try and make sure that all of the features that you're wanting grouped together are within the same sketch. So in this case, I'm doing the two outer sections, the two outer holes or outer sets of holes in one feature, so that they all are toggled on or off at the same time in case that's something we need to go back to. Same with the middle channel, and we're going to add some ones in the middle as well, or the center channel and the middle ones essentially. All I want to do for now quickly as well on top of this is just add some points to each of those construction lines. So I'm going to add a point 1, add a point 2, 3, and 4. and I'm going to dimension their position as a certain value away from the edge of our component. For this one, I believe it was 20 millimeters. We can always come in and change that later on as well. And if we wanted to be clever with this, we've got the ability to come in and say this is going to be the whole offset in the dimension, in the depth, and that's going to be equal to 20 millimeters. So that's something we can again pick up later on if that was something we wanted to grab from within our parameters. So all I need to do now is define the other values as equal to that one by selecting it, and you can see all of the other points are going to be driven by the original item. Not only that, but we'll be able to reference that for all of the other holes, so they've all got the same placement later on. And then we also want to make sure that our hole placement is correct along the side of the part, to make sure that we've got our side plates or whatever's holding up to the side is the right distance from the edge. So I'm just going to add a distance between the construction line and the edge, and I'm going to say that this is going to be equal to thickness, THK, divided by 2. We want it right in the middle of the thickness, and that thickness will be defined throughout the entire assembly. We could even name this if we wanted this to, so we can say that this is the whole offset in the width, and that's going to be equal to that. So it's got its own value now. It's got its own parameter as a named parameter, and we've done that side. So I'm just going to do the same on the other side. Grab there, and place that down there. And if I go and press a little triangle on the side there, I can pick from various other parameters as well. Otherwise, I could type this value in if I know that it is whole offset D, or W in this case. Hit enter, and it grabs that same value. So there are multiple ways of grabbing other values as well as we go through. As soon as I hit finish sketch on here, that's then created for me. All I now need to do, make sure I've got the alignment correct. That's perfect. We're on the bottom of our part. I want to now add in holes for this particular part. So I'm going to go to the hole tool. It should automatically pick up your recent sketches. In 2023, they've added that functionality. I think even up to 2020, they had that functionality. So it'll automatically pick up the sketches that you had last. And we want the depth of this hole to be half of the thickness. We don't want it to go all the way through the part. If we're using dowels, if we're using others, we don't want to change that around. And then the diameter of this one, you just want the whole dia to be equal to 2 millimeters. And we should have that value on all 4 of those points now. So if I hit OK on there, you can see that those holes have now been created on the sides. I just want to visually see that, so I'm going to name that whole feature as side holes. And we're going to do a very similar thing for the other holes as well. So I'm going to go into my another sketch. I'm going to create another sketch on the bottom plate. And this time I'm going to have it right on the center line. So right on the middle snap point of the top and bottom edge. Make that a construction line very quickly. Add those points in again. So I'm going to add a point there and a point there. I'm going to dimension this as my whole offset D, and just dimension the one over here if I can find it. There it is. Again, just going to reference that other one. They'll then be driven by each other. Hit finish sketch. That's now taken us back to the 3D environment. We need to select whole. Notice how it will pick up those same values that we had in the last one, so we're happy with the exact same values. We've got a 2 millimeter for that, and we've got our thickness divided by 2. If we wanted to, we could just make sure that this is definitely referencing whole dia, which is the one that there we go, whole dia. And every time we change that diameter, it changes all of the holes for us. And then I want to make one last one very quickly, which is just going to be in the middle of those. We want to have the ability to add extra edges or extra siding in there to divide this into different components as well. So one last sketch. This time I'm going to go and select a sketch point that is going to be in line with the 2 holes that are always going to be there. So those holes are always going to exist. And then another one over there, if I can get the reference point, there we go. I'm going to add a point again along those two. And I'm just going to dimension them from the midpoint of this line. And I'm going to say this is the mid offset hole mid offset, and that's going to be equal to 30 millimeters for now. And I'm going to do the same on the opposite side and just reference that other value. So you can see we can build in as much information and as much intelligence again into our model as we want to. Now at the same time I can come in and reference the position of each of those. So if I go and place a point there and another point there, I can then say that I want this to be vertically aligned to, not that point, I want it to be vertically aligned to the point itself, and then horizontally aligned to the hole itself. It's not going to pick that up, is it? No, that's fine. I'll just go in and create another construction line. I created construction lines earlier that I applied it to, but I thought I'd be a little lazier this time. Turns out I shouldn't be lazy. So plot that point over there, and then the other one against that same point, and you can see our points are now locked in position. All I need to do now again is finish sketch, apply holes. Again, it picks up from that same sketch. It's picking up hole 1, 2, 3, and 4. Picking up hole diameter, picking up the thickness, or the depth rather, and hit OK on there. So now we've got a component, the tabletop, which has got the right dimensions that we need to, as well as holes in the correct positions that can all be adjusted with the change of a parameter. So if I open up my parameters again once more over here, we've got our width, which will adjust as it needs to, and our hole positions are positioned based on the width and the depth. So as we change those values will then change as well. And we know that our hole offsets are obviously those ones that we've set over there. But if we go a little further down, we've got our hole mid offset, which changes the position of the middle holes. So those holes over there, if I change that offset very quickly to something like 15 millimeters, the position of those middle holes changes then as well. So that's a nice handy one that we could always use later on. Once we're happy with that, I can hit done on here and confirm. We then need to save our part. I'm just going to save this as tabletop. Hit save on there, and our part has been saved. Now we want to bring this into an assembly that has parts that have all got their own parameters as well. So I'm going to go into assembly 2 over here, which I've pre-configured with some sideboards, which will then get attached to that particular component. It's also got a bottom board as well as 4 independent legs as well, which you can see over there. Now what we can do is we can go into our place command, and we want to place that tabletop in, the one we've just created. I want to open that and place it in very quickly over here. Because I've modeled it with the correct alignment, it's come in with the correct alignment, but if we wanted to, we could have even modeled it upside down, and using the assembly environment, make sure that using our constraints, it's positioned correctly. In this case, it is positioned correctly, so we don't have to worry too much about that. So what I'll do for this one is just add in some constraints very quickly. So in our constraints panel, or our relationships panel, we're going to add a constraint between the one hole that we've just created and one of the holes of the sideboard itself. If I can find that over here, that looks like there, and I've chosen the wrong reference. Let me just reselect that very quickly and make sure that it's choosing the axes of that, which looks good to me. I can apply that. What we might want to do is just apply it on the opposite side as well. It doesn't help that the size of this one is currently incorrect. So what I will do very quickly is just make sure of the width and depth of these components using my measuring tool. So we've got a width of 1050 and a depth of 400. So we just want to change those values quickly in here, which is easy enough to do now that we've got the parameters there. So we've got a width of 1050 and we've got a depth of 400. All I need to do now is save. I'm going to my assembly and we should have our board in exactly the right size and dimension now, which will allow us to place that back in with the correct constraints. Makes life so much easier when we're using our constraints and our parameters in there. So using constraints, just going to pick up that point again, rotate our model around, pick the other point, apply that. You'll notice that we've got the two opposite corners applied, so it can't rotate anymore, but it can move up and down. All we want to really do from here is just make sure that the bottom face of our tabletop and the top face of one of the side boards is lined up. So I'm just going to go in there and probably want to use one that'll always be there just to be safe. So maybe one of the side ones will be good. And hit apply on there. We could add in, if we wanted to, the dowels that would fit inside of those. For the sake of this one, I'm not going to add those in. And we have added our legs already. Again, those don't have the fasteners in, but you could add those in as well, depending on how detailed you want the model to be and what you're wanting inside of the bill of materials for that. So now that we've got the components all constrained onto each other correctly, we can now start to add the intelligence to our model itself. So we've got our iLogic panel available to us, or our tab available over here in the model browser or in the browser section. If it wasn't there, if it didn't exist, we've got the ability to add that as a new tab. So if we hit a little plus icon, the iLogic tab would essentially show up inside there. And essentially all we want to do is start to create an iLogic rule. And what iLogic rules will do is start to add some coding, essentially some very base level coding to our parts. So if I right click in here and say I want to add a new rule, this will pop up on my other side. So I'm just going to call this one my table configurator. Hit OK on there. And again, this is open on my other screen, so I'll just bring it across over here. And I know that inside of my table configurator, I'm going to want to have a width, a height, a leg height, I can spell correctly today, and width, height, depth. If we want to comment out and ensure that the code doesn't pick up what we've typed in, we can just put a little hyphen over there, and we've got the ability, sorry, not hyphen, essentially adding a little comment through in the top section over there. And then we've got our leg height and our width aspect. So we've got leg height, width, and depth as well in that section over there. We want to just make sure that when we are creating a rule, we go into our options and make sure that it does not run automatically, because we don't want to have this running automatically without us making sure that everything's saved and ready to go correctly. So if I just hit save here and close this out, we've got the ability to then just save that in the background. What we do also want to make sure, which will make this a lot easier going forward, is that inside of our assembly, we've got the same values that we want to be driving for those. So say for example, we want to have a height, a width, a depth, a leg height, and perhaps we want to change the properties of certain components. So say for example, a appearance or material of an item, we can come in and add those in as custom parameters. So inside of our assembly, we want to be able to create those that then push the same value down to the children, down to the parts from inside there. So if I open up my parameters again very quickly, I've got all of the constraints and parameters inside of that section, but right down at the bottom we've got our user parameters, and these are pretty much custom parameters we can come in and add. So I'm going to add a numeric one over here for our width and say that this is equal to 800. I'm also going to add in a height, and that's going to be equal to 800 and stick. So I'm going to call this one actually let's call it the gap. Or shelf gap. Shelf gap. I'm going to call this 50 millimeters. To confirm and change the width to 800. We also want to have our depth, and that's going to be equal to 500. And we also want to have our leg height equal to, let's say, about 800 to begin with as well. Change this one to 500. And then what we've also got the ability to do in our parameters is make different types of parameters as well. So we've got numeric. We've also got the ability to add text parameters as well. So I'm going to add a text one in here very quickly. And this one is going to be the material. And we'll take a look at that in a few minutes. And if I right click in my equation box, I've got the ability to come in and make this a multi-value equation or multi-value parameter. With that, we've got the ability to come in and add different values for those that we can come in and choose from in a drop-down. So I want to make different materials for the leg. The first one is going to be a steel. The second one is going to be a aluminium, or let's see what other options we've got. We've got a gold as well, which we could probably add in, and then probably a silver. Let's keep to those ones nice and simple. Hit add on there, and you can see that those values have been added down at the bottom over there. If I OK this window very quickly, you can see we've got a drop down value for all of those. So we've got steel, gold and silver that are available. If I hit done on there, those are values that we can then refer to in the background. What we can now do is go back into our table configurator, iLogic rule set, edit the rule with a right click edit, or if you double click on it, it'll also help you edit that. And essentially what we can then begin to do is, you can see we've got the name of our assembly, currently assembly 2. In here we've got our model parameters, and we've now got our user parameters. I can then come in and bring in each of those values. I can say width, if I double click on it, if I go to the next line rather. So we've got width, we've got shelf gap, we've got depth, we've got leg height, and we've got material. Those are values that we want to be driving essentially from here. And these are all parameters, these are all values that are set inside of our component, what in the assembly level. But what we've also got is this little model tree here at the side of that, where we can come in and pick the different values of any of the different items from inside of our component as well. So if I had to come in here and say that I wanted to look at the value of, say for example, my bottom board, I knew that I wanted to set the value, which has been set inside of sketch 2. I believe sketch 2, no, it's in the extrusion. In the sketch 1 we've got our width and our depth. That reverts back to that same value that I set inside of tabletop. So if I go into tabletop and expand that, again it's the same hierarchy that's inside of our assembly. We've got our extrusion 1 and we've got sketch 1. We've got a width and we've got a depth. If I come into this section over here, we know that we're wanting to set our width first. So I'll expand the section down here and say that I want to bring in the value of my tabletop's width. Just by double clicking on it, it'll bring in our parameter, then the name of the parameter, and the name of the component, and what the name of the parameter is. And we can say that this is going to need to be equal to width inside of our top level document. So the value of width inside of tabletop 1 is going to need to be equal to width inside of our current document, inside of assembly 2. We can then come in and actually repeat this process for every single component that's going to need to pick up that value. With width, it's really just going to be the two boards. It's going to be our bottom board, so I'm going to expand that out, go to sketch 1, and just double click on that value, make sure I'm in the correct place, double click on width, and you can see bottom board 1 width is going to be equal to width. So now, no matter what value our width is at the top level, it's going to push that value all the way down into the other components. And then we need to do the same for our height, for our leg height, and our depth. So very quickly go into our depth section. I just want to make sure that we've got our depth value for our bottom board and our depth value for our top. Add those in two separate lines. And now I just want to say this is equal to depth. And if I go here and say this is equal to depth, we've got those values in there. We can then also drive the leg height and the height itself of the gap and drive those essentially in the same process. So whatever the height is that we set inside of those parameters, if I have a look, especially in my legs, not my legs, sorry, my sideboards, the extrusion over there inside of sketch 1, I've got a height dimension and I've got a depth dimension. So in our depth dimension, we could essentially just double click on this over here. And again, say we want to have that equal to depth inside of our assembly. And because I know the naming convention is exactly the same for all of the other ones, I could come in and paste this in a few times. I know there are 4 of them, and all it's doing is changing the instance number. So this is instance 1, instance 2, 3, and 4. So that'll change the value for all of those. I want to remove this in here because I don't need those values directly inside there. So we're now driving the width and the depth of the entire component from the top level. We also want to make sure that when we do run this rule, it then updates everything inside of our assembly. So inside of our, I believe it's the advanced API drawing, we want to make sure that our model is being updated. Could be the advanced API on its own. Make sure that it's in here. Doesn't help that I don't have my glasses on. Document, rather under document, and then document update. So just make sure that we are updating this particular document at the end of this particular script being run. And essentially, once we've got that configured, the other option we've got as well is to be able to set the value of a material from inside of our components. So if we wanted to make sure that we were changing the material, which is considered an I property, if we go down to our I properties, we can come in and set the material of certain components in as well. For that one, we can set an if statement and say that if our custom property, which again we can pick up from here in our user parameters, if our custom material property is set to steel, then we want to push that value down to all of the children as well. And that can either be the legs only, or you could have other values inside there as well. If I close this one off, I'll just show you one of the other scripts we've got from a completed version of this one. So if I go over to my table assembly over here and open up my iLogic table configurator from there, you'll see much in the same way we've got a width section which drives the width of our baseboard and our top board, or bottom board and top board, and we've got the depth which is driving the sideboards as well as the top and bottom board, and then the shelf height is driving the sideboards. We've got a leg height that's driving the leg heights from the top level. And we've got an if statement for the material. So we can say if the material value in our current assembly is equal to steel, then we want to set the I properties of leg 1 material to steel, and same for leg 2, 3, 4. If it's gold, we want to set it to gold. If it's silver, we want to set it to silver. So we can essentially copy that and paste all of those in the values, and we can change those each time. One thing to bear in mind with this material is it needs to be the exact name of the material. So whatever the material name shows up as, we want to set that from inside then. We've also got the ability to set certain other if statements as well. So the fifth and fourth side bracket, or we call them sideboards, we can say that those values or those particular components are either visible or invisible, or active or inactive, whether our width is a certain value or not. So here we have it that if our width is less than 1,000 millimeters, then we want to make sure that the component sideboard 4 and 5 is inactive or false. And the same for the holes that then connect to that particular point. We don't want those to be active at that particular point. Otherwise, if our width is greater than or equal to 1,000 millimeters, we want to make sure that our is active value for those same boards and those same holes is true. So we've got the ability to come in and set those toggles in here. We've got our features, we've got an is active toggle that we can essentially activate here, and that will turn certain features on or off. And then again, at the end of that particular script, we've then got this option over here, which then updates all of the files inside of our component to make sure that everything is dragging through those values and pushing those values throughout. It's a very important one, otherwise it doesn't pick those changes up necessarily. So if I had to now go into my parameters, and down to my user parameters right at the bottom of my list, I've got my width of 1200. If I drop that down to 800, hit enter to confirm, and it hasn't quite updated it in the way I wanted it to, but if I run this rule very quickly, it'll run through the rest of the items. If I'm driving it from the top level, it needs to make sure that it's pushing down there. It's not automatically pushing that value through. So if I say run rule now, you'll see it'll go through and make those changes for me. It's made quite a few different changes over there. Clearly I haven't updated that one for a while. But yeah, if we go and have a look in that list down at the bottom and change our depth from 650 to something like 400, hit down on there, it's changed the value in my document but hasn't pushed it through, and that's what that other little update button does inside of our script. So if I run this over here, run now rule, it'll update that value inside of all of the components essentially. But then we've got a really nice feature on top of that we can essentially make use of. So rather than having to go into our parameters every single time, we've got the ability to create a form where we can manually press that button that updates each of those individual properties, and where we can come in and make changes to those particular properties. So in our iLogic tab in our browser, we've got the ability to add in forms as well. I've already created a different form, which we'll take a look at in a few minutes, but creating the forms is very easy. Essentially all we need to do is go into the forms tab, right click and say we want to add a form. By adding a form to our list over here, it essentially gives us a list of the different parameters that we've got inside of our file. So in our current file, we've got the width parameter. If I double click on that, it'll add it. If I drag it, rather, it'll add it in. We've got our depth that we want to add in. We've got our shelf that we want to add, shelf height and table height that we want to add in. We've also got a leg height. Perhaps we don't want to add the table height, so I'm actually going to delete that one very quickly. So we've got shelf height and leg height, and then we've also got a material that we can come in and add, and you can see the form being constructed on just to the side over here. So this is an example of the form. So we've got a width that we can adjust, we've got a depth, a shelf height, a leg height, and the material itself. With that, we've got a few different options in our little toolbox down at the bottom. So we can either create a tab group which groups certain parameters together into their own individual tabs. We've also got the ability to come in and add a row. This will essentially add a spacer between certain items, or ensure that certain items are together in one single row. So if I wanted my leg height and my shelf height to be in one row together, you can see, if I can get them to add in, there we go. We've got our shelf height and our leg height just next to each other, so we can choose one or the other essentially, and they're right next to each other inside of that section. We've got the ability to come in and add a photo or picture right at the top of our list, or anywhere inside of that list. So if you have certain examples and want to push that across to whoever will be the end user and needs to create the configuration, we've got the ability to add photos in or pictures in as well. We could come in and add an empty space, say for example between depth and the row, just so that it puts that off to the side a bit. We've got the ability to come in and put a label in as well, wherever our label is. Right at the top of that is where I want it, and I can come in and give this a name. So we can give this a option of SA materials. And you can see that that's changed there. Perhaps materials we want to drop to the bottom just above material, or drop material below that rather. And then we could have, instead of material, we could say that this is the leg material, since this is what it's currently driving. We could then have a material for the actual component itself. We can have a material for the connectors, the bolts that are connecting everything together. So we can have different options essentially from inside there as well. What we can also do with each of these individual values is they all have different properties as well. So instead of it just being a generic number format that we can put in here, we can come in and say, for example, we're working with certain standard widths. We can come in and have a list that we can choose from, or different increments that we can choose from essentially from here. So if I select width from inside of our form editor over here, just down towards the bottom of the screen over here, you can see we've got our properties section for the parameters. So we've got a name that we can give this, which fits into the name panel over here. So we can give this any name really we want. It doesn't have to necessarily be the name of the parameter that we're changing. But what we've also got the ability to do is choose the size limits. If we wanted to set certain size limits and make sure that it only fits within a certain range. Or we've got the ability to use and edit the control type. So whether we want it just to be a text field or a slider, we can come in and choose between those two different values. And if I extend the slider properties over here, you can see I'm given the ability to add in a minimum value. Let's say our minimum value is 750. And then we've got a maximum value we can put in here, which let's say is 1200. We've also then got step sizes, so however many steps we want in between that value and what their sizes will be. I think 150 should be okay for this particular one, so I'm just going to choose that there. And you can see we've now got 4 different sizes we can choose from with a slider now. So if I wanted to choose a different value in here, I can slide that along. Do we want this to be a read-only value, or do we want it to be a editable value as well? And then our text location, whether it's left or right or center, we've got the ability to pick that as well from inside there. Right, left, top, bottom. We've also got the different font types available to us, sizes and font style as well, and any size limits again we've got the ability to adjust inside there. And then what we've also got the ability to do is run a rule from inside of the same box. So this box can exist without any iLogic rules, but generally speaking you want to have this alongside an iLogic rule as well. And you can see in our list on the left hand side of the screen here, we've got the ability to pick up our rules in there. So we've got the table configurator rule set. I'm just going to drag it and drop it right to the bottom of this list. Currently it says table configurator. But essentially what I want this to do is I want this to update or run each time I choose to change a certain number of properties. So I don't want this to run every single time, but I want the option to change and run this rule from inside of this form. So I'm going to call this form, or this button rather, the update button. So as soon as you want to update those values inside of your window, we've got the ability to use this update button over here. I've just decided I don't really like the fact that the width is on the right hand side of that, so I'm going to make that at the top rather. So width is sitting on top of the value itself. Once we're happy with that, I can hit OK to confirm, and that will then close off our dialog box, and I can open up form 2 over here, and you can see we've given those different values. So I can come in and change the width in its increments. So I know that I want this at 1050, and I want depth of 500. Shelf height I'm not too worried about, leg height I'm not too worried about, and maybe I want to change the value or the material that's associated to the leg. So I'm going to choose silver, and I'm going to hit update. This will now go and run that rule and apply all of those changes that I've configured inside there. You can see it's added in those extra brackets inside here when it's reached a value that's over 1,000 millimeters. If I go below 1,000 millimeters at 900 and change any other values, I'm going to keep that the same. I can come in and change the shelf height. Let's change the shelf height to 50 and change the leg to a gold leg. I'm going to hit update and it runs through that iLogic script again. Make sure that all of those properties have been updated correctly. And that's essentially the process behind this. So it's a bit of a setup process in order to get these in. But if you are already using parameters and you're already used to ensuring that your models have the correct sizes as you'd need them to, you can see how easy it is to configure this inside of an assembly. This can be configured inside of a part as well if you wanted to. But yeah, it's just really great to have a single component or a single model that's then driving or being driven by our iLogic configurators. So if you do have any parts or assemblies that are very similar to each other minus a few small tweaks together, we've got the ability to come in and choose this rather than having to redesign our models every single time. We've got the ability to use the exact same models we're already using, but just make a few tweaks to certain components, making sure that these are being pushed from the top level down. And we've got then the ability to grab our drawings from this. We've got the ability to grab a bill of materials from this. So it all just simplifies that entire process. If I had to have a look at my bill of materials now very quickly from this assembly, you'll see that we've got the tabletop or the top board. We've got our bottom board. We've got our side boards, 3 of them, and we've got 4 legs as well. If I go into my table configurator over here and bring this value up to 1050, hit update to make sure that it's updated the entire component, I can go back into my bill of materials and you can see that the number of sideboards has changed for me. If you wanted to, you could also turn on the legs. You could turn the values on or off based again on certain widths, certain depths. And so if you wanted an extra leg right in the middle, you've got the ability to have that toggled on if your table gets to a certain width. You could also then have the value of the thickness of our the legs adjust based on the height of our table. Maybe we were having a slightly taller table, something that's going to need to hold a lot bigger load. We want to make the legs of the table a little thicker. Perhaps you want to make it a little smaller, make it a little bit more compact, and we can change the diameter then of the legs as well. So various options that we can adjust from inside here, all with different iLogic statements essentially from there. But yeah, I hope that's been great for you guys. If anybody has any questions, feel free to drop it in the comments, or otherwise get in contact with your Man & Machine contact, and we'll be happy to discuss this any further if that was something that you'd like to have a look at. Other than that, thank you so much for your time today. It's gone a little bit over than what we would normally do, but hoping it's been beneficial for everyone. And I shall see you guys again next time. Thank you very much. Bye.